Welcome to Real-Time Signals Technologies. Today we are going to discuss about building tool Maven. These days in software industry, the process of software development very much rely upon best practices of various tools. The software development teams use various tools like project management, release management, test management and various others. Today we are going to discuss about build management tool. This is one of the most important tool which required in any kind of software development. In this session we are going to discuss about top build management tools. But before that, let's have a quick overview on build management. Build management is actually a process of collecting all the components in a software release, performing all the automated tasks to compile, build and test the system and then deploy onto the development and testing environments in preparation for staging. It has become an important part of software development in testing process. But you cannot simply do build management without tools. It is also important to ensure that tools are selected properly and thoroughly so that each of them provides the desired service. So, without wasting any time, let's have a look on build management tool Maven. What is Maven? Maven is a project management tool which encompasses a project object model, a set of standards, a project lifecycle, a dependency management system, and logic for executing plugin goals at defined phases in a life cycle. Maven provides superset of features found in a build tool. Maven manages project build, reporting, and documentation from a central piece of information. Let's have a look on key feature of Maven tool. Key features. Open source. Based on project object model or POM. Release management and distribution publication. Coherent site of project information. Instant access to new features. Extensible with plugins. Works easily with multiple projects simultaneously. Simple project setup. Maven is more than just build tool. Maven was built considering certain objectives. Maven provides easy build process, uniform build system, quality project information, guidelines for best practices development, achieved characteristics, visibility, reusability, maintainability, comprehensibility, accumulator of knowledge. Let's have a look on key features of Maven tool. Key features. Open source. Based on project object model or POM. Release management and distribution publication. Coherent site of project information. Instant access to new features. Extensible with plugins. Works easily with multiple projects simultaneously. Simple project setup. Maven is centered around the concept of POM files, project object model. A POM file is an XML representation of project resources like source code, test code, dependencies, external jars used, etc. The POM contains references to all of these resources. The POM file should be located in the root directory of the project it belongs to. Here is a diagram illustrating how Maven architecture uses the POM file. 1. Reads pom.xml. 2. Downloads dependencies into local repository. 3. Executes life cycles, build phases and/or goals. 4. Executes plugins. All execute according to selected build profile. Now understand the life cycle of Maven. The sequence of steps, which is defined in order to execute the tasks and goals of any Maven project, is known as build lifecycle in Maven. Maven 2.0 version is basically a build lifecycle oriented, and clearly says that these steps are well defined to get the desired output after the successful execution of the build lifecycle. Maven comes with 3 built-in build lifecycles as shown below. Default. This phase handles the complete deployment of the project. The features of default lifecycle are: 1. Generate sources/generate resources. 2. Compile. 3. Test. 4. Package. 5. Install. 6. Deploy. Clean. This phase involves cleaning of the project for a fresh build and deployment. As mentioned above, this clean phase is used to clean up the project and make it ready for the fresh compile and deployment. The command used for the same is mvn post clean. When this command is invoked, Maven executes the below tasks via executing the below commands internally. 1. mvn pre-clean. 2. MVN clean. 3. MVN post clean. This Maven's clean is a goal, and on executing it cleans up the output directory, target folder, by deleting all the compile files. Site. This phase handles the generating the Java documentation of the project. Apart from cleaning, compiling the source code, building a deployable format of the application, Maven has phase which does more than these phases. This phase is one of the vital features provided by Maven which generates the detailed documentation of any Java project. This project documentation has a dedicated phases involved as listed below. Pre-site, site, post-site, site deploy. The command used in Maven to generate Java docs for a given project is mvn site. Basically, when this command is invoked, Maven calls docs document generation and other report generating plugins. Now we will dig more into the detailed phases involved in the example Maven goals. To invoke a Maven build, you set a lifecycle goal. Each phase is a sequence of goals, and each goal is responsible for a specific task. When we run a phase, all goals bound to this phase are executed in order. Here are some of the phases and default goals bound to them. 1. MVN install. Invokes generate, compile, test, integration test, package, install. There is also a clean, site lifecycle. Invokes just clean. 2. MVN clean compile. Clean all builds and execute generate, compile. 3. MVN compile install. Invokes generate and compile, test, package, integration test, install. 4. MVN test clean. Invokes generate, compile, test then cleans. We can list all goals bound to a specific phase and their plugins using the commands. A typical Maven project has a pom.xml file in a directory structure based on defined conventions. The default directory layout can be overridden using project descriptors, but this is uncommon and discouraged. Going ahead, we'll uncover more details about each standard file and subdirectory. 1. The root directory. This directory serves as the root of every Maven project. Let's take a closer look at the standard files and subdirectories that are typically found at root. Maven project/pom.xml defines dependencies and modules needed during the build lifecycle of a Maven project. Maven project/license.txt licensing information of the project. Maven project/readme.txt summary of the project. Maven project/notice.txt information about third-party libraries used in the project. Maven project/src/main contains source code and resources that become part of the artifact. Maven project/src/test holds all the test code and resources. Maven project/src/it usually reserved for integration tests used by the Maven failsafe plugin. Maven project/src/site site documentation created using the Maven site plugin. Maven project/src/assembly assembly configuration for packaging binaries. 2. The src/main directory. As the name indicates, src/main is the most important directory of a Maven project. Anything that is supposed to be part of an artifact, be it a jar or a war, should be present here. Its subdirectories are src/main/java, Java source code for the artifact. src/main/resources, configuration files and others such as internationalization files, per environment configuration files, and XML configurations. src/main/webapp, for web applications, contains resources like JavaScript, CSS, HTML files, view templates, and images. src/main/filters contains files that inject values into configuration properties in the resources folder during the build phase. 3. The src/test directory. The directory src/test is the place where tests of each component in the application reside. Note that none of these directories or files will become part of the artifact. Let's see its subdirectories. src/test/java, Java source code for tests. src/test/resources, configuration files and others used by tests. src/test/filters, contains files that inject values into configuration properties in the resources folder during the test phase. Guide to naming conventions on grouped, artifacted, and version. GAV. Grouped uniquely identifies your project across all projects, so we need to enforce a naming schema. A grouped must follow Java's package name rules. This means it must start with a reverse domain name you control. You can create as many subgroups as you want. Look at more information about package names, e.g. org.apache.maven, org.apache.commons. A good way to determine the granularity of the grouped is to use the project structure. That is, if the current project is a multiple module project, it should append a new identifier to the parent's grouped. For example, org.apache.maven, org.apache.maven.plugins, org.apache.maven.reporting. Artifacted is the name of the jar without version. If you created it, then you can choose whatever name you want with lowercase letters and no strange symbols. If it's a third-party jar, you have to take the name of the jar as it's distributed, e.g. Maven, Commons Math. Version. If you distribute it, then you can choose any typical version with numbers and dots, 1.0, 1.1, 1.0.1. Don't use dates as they are usually associated with snapshot, nightly, builds. If it's a third-party artifact, you have to use their version number whatever it is, and as strange as it can look. Maven is one of the handy tool which can be set up quickly and can be made it ready for any Java projects within a max of 10 minutes. Also, the Maven downloadable package is also very lightweight. Follow the below mentioned steps in order to download and set up the Maven in the Windows environment. 1. Download the latest version of the Maven from http://maven.apache.org website. 2. Once the download is successful, unzip the downloaded Maven zip and place it in a drive containing all the Java-related artifacts. For example, d://java/apache maven 3.2.5. In case you have downloaded any other latest release, then the version may differ, but that's not a problem. 3. Now we need to set up the class path Java_home, and Maven, m2_home. If you already have Java_home set, then you only need to set m2_home for Maven. Kindly ensure that the required version of the JDK has been installed. Now edit the variable path in the system variables to include the Java_home and m2_home. 4. If the above steps are carried out successfully, then we are done with the installation and setup process of the Maven tool. Now in this final step, we would be verifying for the same and ensure things are fine accordingly. 5. Just open up the command prompt from the start, > command prompt, and in the command prompt just type the Maven command mvn version and press enter. It will display the results and confirms that our Maven setup is successful and completed. A Maven repository is a directory to store all the project jars, library jar, plugins or any other artifacts. There are 3 types of Maven repository. 1. Local. Maven local repository is a local folder on your machine. Maven local repository is created when you run any Maven command for the first time. Maven local repository stores all dependency library jars, plugin jars, etc. on your development machine. When Maven downloads the dependency jars, it stores the jar files in the local Maven repository. If a newer version is needed, Maven would download the newer version. If the version being declared in the dependency element in pom.xml file is already in the local Maven repository, it just uses it without downloading. Local Maven repository avoid referencing to dependencies stored on remote machine every time a project is built. By default, Maven creates the local repository under %user_home% directory. After setting the new local repository folder when running Maven command, Maven will download dependencies to the custom path. 2. Central. Maven Central Repository is repository managed by Maven community. Maven Central Repository contains a large number of commonly used libraries, and we can publish our own libraries to Maven Central Repository as well. When Maven cannot find any dependency jar file in your local repository, it starts searching in Maven Central Repository using following URL: http://repo1.maven.org/maven2/. We don't need to configure the Maven Central Repository URL, but we do need internet access to download and search the Maven Central Repository. 3. Remote. Sometime we need to set up a Maven repository inside a company or a project development team to host our own libraries. The company maintained repository is outside developer's machine and is called Maven Remove Repository. Now let's understand important topic POM. POM stands for Project Object Model. It is fundamental unit of work in Maven. It is an XML file that resides in the base directory of the project as pom.xml. The POM contains information about the project and various configuration detail used by Maven to build the projects. POM also contains the goals and plugins. While executing a task or goal, Maven looks for the POM in the current directory. It reads the POM, gets the needed configuration information, and then executes the goal. Some of the configuration that can be specified in the POM are following: project dependencies, plugins, goals, build profiles, project version, developers, mailing list. Before creating a POM, we should first decide the project group, group ID, its name, artifact ID, and its version, as these attributes help in uniquely identifying the project in repository. What are Maven plugins? Maven is actually a plugin execution framework where every task is actually done by plugins. Maven plugins are generally used to create jar file, create war file, compile code files, unit testing of code, create project documentation, create project reports. A plugin generally provides a set of goals, which can be executed using the following syntax: -mvn, plugin name, goal name. For example, a Java project can be compiled with the Maven compiler plugin's compile goal by running the following command: mvn compiler compile. Plugin types: 1. Build plugins. 2. Reporting plugins. Plugins are specified in pom.xml using plugins element. Each plugin can have multiple goals. You can define phase from where plugin should start its processing using its phase element. You can configure tasks to be executed by binding them to goals of plugin. That's it, Maven will handle the rest. It will download the plugin if not available in local repository. Let's have a look at this following example. We've used Maven and Tune plugin extensively in our examples to print data on console. Refer Build Profiles chapter. Let us understand it in a better way and create a pom.xml in c:\mvn/project folder. Next, open the command console and go to the folder containing pom.xml and execute the following mvn command: c:\mvn/project mvn clean. Maven will start processing and displaying the clean phase of clean lifecycle. The above example illustrates the following key concepts: plugins are specified in pom.xml using plugins element. Each plugin can have multiple goals. You can define phase from where plugin should start its processing using its phase element. We've used clean phase. You can configure tasks to be executed by binding them to goals of plugin. We've bound echo task with run goal of Maven and Tune plugin. Maven will then download the plugin if not available in local repository and start its processing. Now let's get deeper into snapshots. A large software application generally consists of multiple modules, and it is a common scenario where multiple teams are working on different modules of same application. For example, consider a team is working on the front end of the application as AppUI project, appui.jar:1.0, and they are using data service project, dataservice.jar:1.0. Now it may happen that team working on data service is undergoing bug fixing or enhancements at rapid pace and they are releasing the library to remote repository almost every other day. Now if data service team uploads a new version every other day, then following problems will arise minus. Data service team should tell app UI team every time when they have released an updated code. App UI team required to update their pom.xml regularly to get the updated version. To handle such kind of situation, snapshot concept comes into play. What is snapshot? Snapshot is a special version that indicates a current development copy. Unlike regular versions, Maven checks for a new snapshot version in a remote repository for every build. Now data service team will release snapshot of its updated code every time to repository, say data service 1.0 snapshot, replacing an older snapshot jar. First, we'll discuss what's a multi-module project and have a look at the benefits of following this approach. Then we'll set up our sample project. For a good introduction to Maven, a multi-module project is built from an aggregator POM that manages a group of submodules. In most cases, the aggregator is located in the project's root directory and must have packaging of type POM. Now, the submodules are regular Maven projects, and they can be built separately or through the aggregator POM. By building the project through the aggregator POM, each project that has packaging type different than POM will result in a built archive file. Benefits of using multi-modules. The significant advantage of using this approach is that we may reduce duplication. Let's say we have an application which consists of several modules. Let it be a front-end module and a back-end module. Now, we work on both of them and change functionality which affects the two. In that case, without a specialized build tool, we'll have to build both components separately or write a script which would compile the code, run tests and show the results. Then, after we get even more modules in the project, it will become harder to manage and maintain. Besides, in the real world, projects may need certain Maven plugins to perform various operations during build lifecycle, share dependencies and profiles or include other BOM projects. Therefore, when leveraging multi-modules, we can build our application's modules in a single command and if the order matters, Maven will figure this out for us. Also, we can share a vast amount of configuration with other modules. One of the core features of Maven is dependency management. Managing dependencies is a difficult task once we've to deal with multi-module projects, consisting of hundreds of modules/sub-projects. Maven provides a high degree of control to manage such scenarios. Transitive dependencies discovery. It is pretty often a case when a library, say A, depends upon other library, say B. In case another project C wants to use A, then that project requires to use library B too. Maven helps to avoid such requirements to discover all the libraries required. Maven does so by reading project files, pom.xml, of dependencies, figure out their dependencies and so on. We only need to define direct dependency in each project POM. Maven handles the rest automatically. With transitive dependencies, the graph of included libraries can quickly grow to a large extent. Cases can arise when there are duplicate libraries. Maven provides few features to control extent of transitive dependencies. Dependency management. Usually, we have a set of projects under a common project. In such case, we can create a common POM having all the common dependencies and then make this POM the parent of sub-projects POMs. Following example will help you understand this concept. Following are the detail of the above dependency graph minus. App UI war depends upon app core lib and app data lib. Root is parent of app core lib and app data lib. Root defines lib1, lib2, lib3 as dependencies in its dependency section. From above example, we can learn the following key concepts minus. Common dependencies can be placed at single place using concept of parent POM. Dependencies of app data lib and app core lib project are listed in root project. See the packaging type of root. It is POM. There is no need to specify lib1, lib2, lib3 as dependency in app UI war. Maven use the transitive dependency mechanism to manage such detail. In project development, normally a deployment process consists of the following steps. Check in the code from all project in progress into the SVN, version control system, or source code repository and tag it. Download the complete source code from SVN. Build the application. Store the build output either WAR or your file to a common network location. Get the file from network and deploy the file to the production site. Updated the documentation with date and updated version number of the application. Problem statement. There are normally multiple people involved in the above-mentioned deployment process. One team may handle check-in of code, other may handle build and so on. It is very likely that any step may be missed out due to manual efforts involved and owing to multi-team environment. For example, older build may not be replaced on network machine and deployment team deployed the older build again. Solution. Automate the deployment process by combining the following. Maven, to build and release projects. Subversion, source code repository, to manage source code. Remote repository manager, JFrog/Nexus, to manage project binaries. We can update the Maven version by following. 1. Open the terminal and move to the /opt directory. 2. Extract the Apache Maven archive into the opt directory. 3. Edit the /etc/environment file and add the following environment variable. 4. Update the MVN command using Maven. Here you will learn how to create /build/deploy and run a web application. Create web application. To create a simple Java web application, we will use Maven Archetype Web App plugin. So, let's open the command console, go to the c:\mvn directory and execute the following mvn command. Go to c:\mvn directory where you had created your Open Consumer Banking folder and execute the following command. Open c:\mvn/consumer banking/target/site folder. Click on index.html to see the documentation. The following are the command line options generally used in Maven commands according to requirement. D. Defines a system property. P. Activates a profile. O. Works offline without accessing network. F. Specifies an alternate of pom.xml. S. Alternate settings.xml. Fn. Never fail the build. Q. Show only errors. X. Debug output. Software quality is defined as a field of study and practice that describes the desirable attributes of software products. There are two main approaches to software quality: defect management and quality attributes. Test case. A test case is usually a sequence of steps to test the correct behavior/functionality, features of an application. Types of testing. Unit testing. A unit test is a test written by the programmer to verify that a relatively small piece of code is doing what it is intended to do. Integration testing. An integration test is done to demonstrate that different pieces of the system work together, usually tested by the developers. Smoke testing. Smoke testing is a surface-level testing to verify/ensure that build provided/given by development team to QA team is ready for further testing. System testing. It's a functional testing where entire system is tested as per the requirements. Based on overall requirements specifications, covers all combined parts of a system. Regression testing. Regression testing is done when any code modification is done to the existing software application, or any new module is added to the existing application. Testing the application as a whole for the modification in any module or functionality. Performance testing. Performance testing is the testing to assess the speed and effectiveness of the system and to make sure it is generating results within a specified time as in performance requirements. Beta testing. Beta testing is the testing which is done by end users, a team outside development, or publicly releasing full pre-version of the product which is known as beta version. The aim of beta testing is to cover unexpected errors. Code coverage is a measure used to describe the degree to which the source code of a program is executed when a particular test suite runs. It is a measurement of how many lines/blocks/arcs of your code are executed while an application is running. Determine the amount of code being tested and not tested. Eliminate dead code, remove code which doesn't affect the program results. Identifying additional test cases which might have been missed in the test suite. Program with high code coverage has a lower chance of containing undetected bugs. Basic coverage criteria. Function coverage has each function or subroutine in the program been called. Statement coverage has each statement in the program been executed. Branch coverage has all decisions been executed for both the true and false cases. Condition coverage has each Boolean sub-expression evaluated both to true and false. Code coverage metrics. It would be nice to be able to achieve 100% coverage for all the criteria, but that is probably not a sensible goal. The coverage percent depends on various factors to decide, like 1. Cost of failure. 2. What the software or hardware will be used for and by. 3. How many people, how late into the project you start using code coverage. 4. Priorities of the project. 5. The way the software is designed. Greater than 90% would be an ideal percentage. Code coverage tools: JTest, Kobatora, Emma, Jkov, Jakoko. The following instruction set will execute to add Maven Code Coverage plugin. Just write and hit enter. Source code analysis. 1. Software security is a very important concern for today's software market, where they have to make their code safe in an almost infinite number of scenarios and configurations, and for which a code analysis of the project is very much essential before it is distributed. 2. Traditional review methods are expensive and cannot test more complex code base, hence it is necessary to auto-detect the flaws as soon as possible in the SDLC. Static code analysis. 1. It is a software verification activity in which source code is analyzed for quality, safety and security. 2. This analysis enables software developers and testers to identify and diagnose various types of bugs/errors such as overflows, divide by zero, memory and pointer errors, runtime errors, and other issues. 3. It functions by reviewing the code without actually executing the code. Benefits. 1. Static analysis scans all code. We will have a higher probability of finding those vulnerabilities which are not even used. 2. You can define your project-specific rules, and they will be ensured to follow without any manual intervention. 3. SCA can be part of build process where they can find the bug early in development cycle, which means less cost to fix them. 4. Target zero warnings from code analysis from the beginning of the project. 5. Faster release cycles. What is Sonar Qube? Formerly known simply as Sonar, Sonar Qube is an open-source tool that can inspect both the source code and the compiled code of over 20 different languages, including JavaScript, C#, Kotlin and Objective-C. It generates a variety of reports that fall into several compartmentalized categories. The steps to install, configure and run Sonar Qube work for all languages. Sonar Qube metrics. Continuous inspection of code generates Sonar Qube metrics that fall into 7 categories. They're often referred to professionally as the 7 axes of code quality, or more colloquially as the software developer's 7 deadly sins. Those 7 deadly Sonar Qube metrics are: 1. Common anti-patterns and coding flaws that can lead to bugs. These Sonar Qube metrics are similar to what static code analysis tools, such as PMD and Find Bugs, typically report. 2. Breaches of coding standards and conventions. These Sonar Qube metrics are similar to what might be generated by the Maven Check Style plugin. 3. Copy and pasting of code. This causes needless bloat and duplication. 4. A lack of unit tests and less than satisfactory unit test code coverage. This is similar to the type of metrics generated by the Jakoko Maven plugin. 5. Excessive code complexity. This is indicated by a McCabe cyclomatic complexity calculation performed on the source code. 6. a spaghetti-like design. This makes tracing application flow difficult. 7. A lack of comments or too many comments. Nobody is quite sure if it's good or bad to comment code. Whichever side of the fence you sit on, there's a Sonar Qube metric to help you quantify what is going on in the code base. Sonar Qube download and installation. There are many ways to configure Sonar Qube. You can deploy the tool to an application server, such as Tomcat or WebSphere Liberty, or use an external database to persist continuous inspection results. But, for this Sonar Qube tutorial, we will perform a simple and basic installation. You simply need to download the Sonar Qube Community Edition and extract the compressed file to a sensible location on the hard drive. In this Sonar Qube tutorial, the binaries are unzipped to a folder named c:\_sonarqube 7.2.1. The Sonar Qube continuous inspection tool starts by finding the start Sonar batch or shell script. This script can be found under the architecture-specific subdirectory in the installations bin folder. On a Windows 32-bit machine, the command would be executed as follows: c:\_sonarqube 7.2.1 /bin/Windows x86 32 greater than start sonar.bat.